Hi everybody. In this tutorial I'm going to show you how to create longitudinal sections using contours, which will show the level difference of the change in level difference along a very long distance. So this particular tutorial requires the use of a software called QGIS, and it also requires that you install a free plugin from QGIS called Terrain Profile. So basically, by the end of this whole tutorial, you'll be able to create a longitudinal section if you wanted to analyze a long piece of footpath or a long piece of road in a fairly a quick manner. So using contours and a rasterized file. So take for example, this suburb of Box Hill. I want to cut a long section just to see what the topography is like along Station Street, and I can use my terrain profile software to do that very quickly without having to manually count count the levels and using the contours. If I basically just draw a line along Station Street in the area that I want to cut and double click, and then I turn on my rasterized file, and then I add that layer into my terrain profile, and you can just begin to see then, and then once you've added that in, you can hide away the raster, and you can just begin to see how much of a level difference there is on Station Street in terms of slope, which I think is a really useful tool, particularly if you're a city planner or an urban designer or an architect and you need to understand the levels in difference along a really long piece of footpath. But what's even better about this particular tool is that once you've drawn this line, you can actually export this line as a DXF file, and basically import it into AutoCAD or Adobe Illustrator to do even more analysis or to make it look a bit more graphically pleasing. So without further ado, let's go into the tutorial. I might just get rid of this and I might just start afresh. Just while I'm doing this, I'm going to leave a link in the description box below, just so that people can download the contours that I'm using for this tutorial, in case anyone wants to replicate what I'm doing. But obviously, if you're doing your own area, then feel free to source your own contours from from the web or any other place that you may be able to find them. So first thing is, in QGIS, I'm going to just make sure that the terrain profile is actually added in as a plugin. Now, as you all can see, I've already got the terrain profile added into my QGIS, but nevertheless, if you don't have it, all you'll need to do is go into plugins and click manage and install plugins, and this will connect you into the plugin repository. They're all free to install, so you just need to scroll down and look for the plugin profile tool. Highlight that, and then where this currently says reinstall plugin, it'll normally say install plugin. So you just click on install plugin, and once you've installed it, make sure it's ticked on the side here, and then it will appear up on your QGIS user interface. If it doesn't appear on the user interface, go back into plugins and go profile tool, and actually click and activate the terrain profile, and that'll allow you to manually activate it. Oops. So sorry, get rid of that. So with that being said, the first thing I'm going to do on my QGIS is activate the OpenStreetMap. Now it's loaded the whole world. The area that I'm going to be focusing on is an area in Melbourne, Victoria, Australia, specifically a suburb in the eastern side of eastern suburbs called Box Hill. So I've just looked at this neighborhood here, and then what I'm going to do is I'm going to import my my contour lines in. They are a shape file, and they are obviously they're a line drawing as well. So you can see how now I've imported in my contours. And we'll just hide that. You can see the contour lines just there. So what I'm going to do now is, once I've got my contour lines, I'm going to convert these contour lines into a black and white DEM file or a raster file, which is the black and white photo you saw at the beginning of the tutorial. And this DEM file is what will allow our terrain profile tool to be able to recognize the difference in levels. In other words, using the different shades between black and white to be able to ascertain the difference in levels. So once you've imported the contours in, go to Raster Conversion, and then click on Rasterize. Now, it opens up a new panel. It asks you to identify the input layer. So the input layer is my contour line file, which is the series of letters and numbers. I've just been a bit lazy. I haven't relabeled it. But the input file is the contour file that we want to create the raster file from. So click on that. And then for the field to use for a burn-in value, what this means is it needs a series of data to create the black and white photo. So theoretically, it should be a numeric selection. So in this instance, I'm going to select altitude because that's that's the difference in levels for my contour. I'm not going to worry about the fixed value to burn. I'm going to make this a reasonably high resolution, but not too blurry photo. So I might just make this 100 by 100. Feel free to play around with the numbers if you like, but I think 100 by 100 works pretty well. The output extent, now we need to just basically use the layer extent. In other words, we need to tell QGIS that we want the area of the raster to match the area of the contour, as opposed to letting the raster file go off in a random location. So we're going to use layer extent, and we're going to locate the raster based on the layer extent, which is the same as the contour. So click on that one and click OK. We don't have to worry too much about this, and we don't have to worry too much about any of these as well. So once that's done, click Run, and then just in a matter of seconds, it'll automatically generate a pixelated black and white raster file over generally covering the contour line areas. And then basically we have what we need to start our analysis. So I might just open up the terrain profile tool, just this little icon here. And then what I'm going to do is I'm going to highlight the rasterized photo. Oops, sorry, that's a mistake. I'm going to highlight the layer that contains the raster raster file, and then I'm going to click Add Layer. This will tell the profile tool which raster file it is actually testing that it is generating the long section drawing from. So once you've added that in, then all we need to do is, with the profile tool still activated, just click and just drag our mouse to the area in which we want to section. And then once we're comfortable with the extent of line, double click. And that's pretty much it. And that's a very quick way that you can analyze the contours over a long distance without having to create a 3D model and section it off or manually count the contours yourself. And with an added bonus, you can export this line into a 2D line as a DXF file, so that you can then transport it into AutoCAD or Illustrator. And obviously, if you wanted to do that, you just click Save As. But really, this, as you can see, as I'm dragging my cursor, you can see the red square here move along with it as well. So it's a really useful tool to be able to test long sections in a quick and efficient manner. And also, you're not bounded by a straight line. In fact, what you can also do, so just click out. You can also actually draw diagonal lines as well. So let's just say you wanted to measure the line of this road. Again, you can see that it doesn't have to conform to a straight line in order to measure. It'll actually you know, use it'll follow the line that you've drawn, so you don't have to draw a straight line all the time. And that's it, guys. Thank you so much for watching. Hope you found this to be helpful.